The inverse square law, practical use. As I've said several times before, I never actually do the math of the inverse square law. I'm focusing on the practicality. So if you're not comfortable with the math, feel free to throw it out the window, and let's just focus on what you really need to know when you're working in the studio. We're going to take a moment to take a look at the practical uses you have to understand. Practical application number 1. When I move the distance between my light and my subject, I change the exposure or the amount of light falling on my subject. So if I would like more light on my subject, I want the subject to be brighter, I move the light closer. If I want less light on my subject, I want the subject to be dimmer, I back the light away. So for example, let's say I take this shot, and I look at it, and it's underexposed. Okay, there's not enough light. Well, let's say that I don't want to change my aperture. I'm at f11, that's actually the depth of field that I want for this shot. Well, I could change the power of the light, but what happens if the light is already at full power? What I can do is I can move that light closer in. Or maybe I just don't want to bother with the power of the light. So now I can move the light in. I'm going to brighten up my exposure. Perfect. And now it's perfectly beautifully exposed. There is math going on behind the scenes. I don't usually worry about that math, but if I want to make sure that I have the correct exposure, I can go ahead and take a meter reading to make sure that now, once I've moved the light in, it is at f11, 1/200th of a second, ISO 200. So I can make sure it matches the settings on my camera. So 1/200th of a second, ISO 200. Let's take a meter reading. Perfect. So gets the right exposure, but if it were not the correct exposure, all I need to do is bring it in closer or pull it further away to adjust. Now I'm going to do the same thing, but the opposite direction. So let's say I'm taking a shot in the studio and it looks overexposed. So let's grab the shot. And the light on her face, it's too bright. But I like where my camera settings are at. Again, 1/200th of a second, ISO 100, f11. So if I don't want to mess with the power of my light, I can simply pull the light away. As I pull it away, the exposure, the intensity of the light on the subject will get dimmer. So let's pull it away a little bit and try it again. And the exposure looks much better, but it takes you a long time to figure out what correctly exposed is. So you can guess and get it to looking good. I think that's fine. Or if you want to use a meter, you can actually check and see if you got to the correct aperture by pulling the light away. So what you can do is you can move the light further away until it looks like it's the right exposure. However, especially when you're first starting out, sometimes it's hard to tell what the right exposure is. That takes some time to train your eye. And so this is an instance when a meter might actually be helpful, because what I can do is I know that my target is to get it to be an exposure of f11. So I can move it the distance I think is appropriate and then go take a reading. And if it's not right, move the light in closer if I need more light, or further away if I need less, right? So this will help me out. Let's get a reading. I'm aiming for f11. Perfect. And so I'm able to get it closer to the f11 I'm aiming for without having to guess and not know for sure that I've got the actual right exposure in my camera. So let's take that one more shot. And now I know for certain that I'm correctly exposed. When I compare the two shots, minimal difference. So you can go by your intuition or go by the numbers. Practical application number 2. The fall off of the light changes based upon the distance of the light to the subject. So we're going for practical usage here, and I use this information all the time. So let's talk about when it would actually be useful to you. First example would be if you want the background to get lighter or darker. And so in this instance, I'm going to take a sample shot and then figure out how to use distance to make the background darker. You should already know the direction that we're going to be going here. So let's get a quick shot. All right, so if I want my background to get darker, I can bring the light in closer to the subject, because when that distance between them is diminished, when they're closer together, the light's going to fall off more quickly towards the background. All right, so let's bring it in. Great. I know that the light is going to get brighter because I brought it in, so I'm going to read meter. Okay. And the background is now completely black. So that's practical application number one, is you can change your background lighter or darker. But now let's talk about an example when you're lighting a group or a scene and you want it to be more evenly lit. Another way to think about how the distance of light to the subject changes your shot actually is really practical when you're photographing groups. It's going to allow me to light a group more evenly. It's the inverse square law, but I don't really think of it that way. I'm thinking of it much more practically. So I'm going to grab two of my assistants, bring them out here for a group shot. So ladies. Okay, perfect. So in this instance, I'm going to start with the light off to the side, and this perhaps looks familiar to you. Imagine the gradient down the wall. What's happening? Whoever's closest to the light is going to be brighter. And then as we move away from that light, it gets dimmer and dimmer. So I already know that this group is not going to be evenly lit because the fall off of light, because of the inverse square law. So let's grab a shot. Okay, so if you notice on the right-hand side, my subject is much, much brighter. And then all the way over to the left, everybody gets dimmer and dimmer. And so it's just not an even exposure. So what can I do so that one person isn't so much closer to the light than everyone else? Because again, right, we're doubling the distance, quartering the power. We're losing 75% of the light. Well, one thing I could do is I could move them all in a little closer. Come just a little closer to each other. Perfect. So I've reduced the distance a little bit, but because the light is so close, the light's still falling off dramatically. It's still getting much dimmer very quickly. So I can move my light. As I move my light away, it's like putting them further down that gradient. The further away they are from the light, the less the light is falling off dramatically. Basically, the light evens out. That fall off evens out. So if the fall off is more even, they'll be more evenly lit. So I can also move the light around front a little bit more if I want, because now she's not that much closer than the girl on the left. Everyone's a little bit more of an even distance than if I'm far off to the side. I also know, because I backed up my light, the exposure is going to get darker. I know that this is how it works. So I will have to compensate. So first of all, it's too dark. I could brighten up my light, or I can open up my aperture. One reason to be careful of opening up your aperture too much with groups is that if you have people stacked, if you're shooting with a narrow aperture, you'll struggle to get everybody in focus. So that's an instance where you might want to bump up the power. In this case, I just opened up the aperture. I only needed to go to, say, f10. And if you look, everyone is pretty much completely evenly lit. So if you're lighting a group, what you should take away from this is you don't want the light to be super close to any one side or person in the frame, because it's going to make them brighter and the light will fall off too quickly. So what you need to do is pull the light out so it's a little bit more evenly spaced from everyone. It's like moving them further from the light makes that gradient of fall off. It makes everything pretty even, and then you get even exposures on your group. So don't keep the light super close. Try to pull it away just a little bit, but not so far that you make the light hard light. Now you can see how the distance of the light to the subject makes a difference in groups, right? If it's in too close, the light falls off too dramatically. But guess what? The same thing happens when you're photographing a single person. Let's say that you're in a really small space and you have a person with their elbow up or raised. When the light's in really close, it's basically that same idea of the group. What's close to the light's going to be really bright, and then it falls off quickly. So if you are lighting a subject and one part of the body, maybe it's a foot or the arm or something, is much brighter than the rest of it, backing up your light is going to help even out the exposure. So let's take an instance. Give me a little handout to the side. So if you've got your light in real close, all right, what happens is from the hand, you're already double the distance by the time you're at her face, which means you're already at 75% of the light falling off, falling away, just in the distance from the hand to the face. So the exposure is going to be totally off. So let's grab a shot so you can see that fall off of light. So that hand is much, much brighter than the face. By the time we've gotten to the face, we've lost 75% of the light already. So what can I do to make it more even? If I back up the light, what it's going to do, it's going to more evenly light my subject. So let's just back it up a little bit. I know that when I do this, however, that I am going to lose light. I've pulled the light away, some of the light falls off, so I will need to adjust with my exposure, so I'm going to open up my exposure a bit. Perfect. And so you'll see, although the exposure is not completely the same between the hand and the face, it is much more similar than the prior shot. So basically backing the light up more evenly lights the scene, whether it's a group or a person. Practical application number 3. Things that are closer together are going to be more similarly lit. Things that are further apart are going to be lit independently. This has a lot of practical uses, but in this first example, the use that I think about it most often is when I'm photographing groups. If the group is too deep, if it's stacked too deep, the people in the back aren't going to get enough light because it's the inverse square law. The further away they are, the more the light falls off. So what I try to do is I try to reduce the distance. I try to put everyone closer to the same plane, so relatively there's similar distance from that main light. So will you guys come out, and I'm going to have you kind of just give me a stacked shot. Maybe you're shooting in the studio and you're trying to be cool, so you're stacking, so it's like an album cover, right? So some people are in the foreground, some people are in the background. Perfect. So if I take this shot, if you look at this shot, it's not that the difference in exposure is massive, but the person in the front is definitely brighter than the person in the back. I want everyone evenly lit because this is a group shot. So what I can do is I can reduce the depth, the distance between them. And I flatten that out and I put them all in the same plane or similar. It makes the distance between the light and each of the subjects about the same. So if I want things to be similarly lit, I need to have them a similar distance from the light. So for example, can you guys squish right up, close the distance between you, right? And Raquel, come in just a little bit more. Perfect. So same thing, all I've done is I've squished them in closer together, and you see that already the exposure is much more even. So as you can see, bringing them together like this, eliminating that depth has put them all a similar distance from the light, and therefore having them be similarly exposed. In the examples I just provided, these are the scenarios that I see play out over and over again in my work. And I'm using the inverse square law, but it's taking place behind the scenes. I'm not actually calculating the math. The important part is that I understand how this is affecting my imagery and the way I work in the studio. Light as a cone. If you look up diagrams of the inverse square law, you'll actually see that light is shaped kind of like a cone, because in the beginning, it's a point light source. It's very focused. And then as light leaves the light source, it spreads out in all directions. I use this knowledge all the time when I'm trying to control the spread of my light. I'm controlling how the light hits my subject and also illuminates my scene. When I want to restrict the light, not let it spread all over, what I do is I bring the light closer. It doesn't have time to spread out. Now I may also use a grid, but this is something we'll talk about later on. By bringing the light in, it gives the light less time to spread out. And if I want the light to hit more of the scene or light the entire scene, what I'm going to do is bring the light back further. It gives it more time to spread out. Let's take a look at this in action. I know that when I bring my light source in close to a subject, it's going to stay more focused. As soon as I step the light a little bit further away, the light begins to spread out. So whenever I want more focus, I bring that light nice and close in, and I can actually illustrate that with a bare head against this wall. Notice, I'm going to bring it so that the light is almost right up against the wall, and you'll see the area of the spread of light. This is, in fact, part of the inverse square law in action, and it is the way that light, once it leaves the light source, spreads out in the shape of a cone. But I just think of it practically. Move it in to have it more focused, pull it back to have a wider spread. When I'm trying to light somebody full length from head to toe, a lot of times if I have a smaller light source, I do have to move it back a little bit so the light has more room to spread out and actually illuminate their entire body. So let's move this light in nice and close, nearly up to the wall. So right now I'm about an inch away from the wall, and you see how focused that light is. Now let me pull it back so it's 4 inches. It's already spread out quite a bit. Now I'm going to actually start pulling the light back. Watch how it begins to spread out further and further and further. So this is, in fact, the inverse square law, but I'm not doing any of the math. I just know focused, bring it in close, want more spread, pull it back further. And another way that I like to think about this is I think of light like a bucket of water. So I actually have a light modifier or a little bucket right here. If my subject is really close to that bucket of water and I throw the water, it's all going to be focused right in one place, because it doesn't have room to spread out. However, if I back that bucket up further and I throw the water, it has time to spread out and get the person wet head to toe, and light acts very similar. So whatever makes it easier for you to remember, but the practicality of it is what's important.